All right, so last section we're going to look at is 4.4. Yesterday we talked about a few examples of radical functions. Okay? And there's a couple examples on the board. And then we went through some different terms. So I think I had added in expression there, radical expression. So a radical expression is anything that has that form. That's not an equation because it doesn't have an equal sign. The two above are radical equations. That's an expression. This number that you have on the outside is the type of root you're doing. That's called the index. What's underneath the root, that is called the radicand. And the actual root symbol itself, you can call it the radical symbol, the radical sign, the root sign, anything like that. Now, when you put a radical like that, there is no index written. What did we say the index is if you don't write it? 2. 2. Yep. So if there's no index, we always assume that it's a 2. All right. And that's pretty much where we left off. So sometimes we have a problem that has a radical in it, like this. And for some reason, we don't want to have a radical. If you don't want to write something as a radical, you can avoid that. And you can use an exponent that's a fraction instead. If I were to rewrite this one, does anybody know what power you could raise 3x to? And it would be exactly the same as taking the square root of it. Yep. The 1/2. Yep, exactly. Raising something to the 1/2 power is exactly the same as a square root. Here's an example. What's the square root of 16? 4. 16 to the 1/2 power? 4. So raising to the 1/2 power and taking a square root is the same thing. How about a cube root? Anybody have a guess what power you could raise something to? And it would be the same as doing a cube root. Yeah. The 1/3. Yeah. It's basically 1 over the index. If you want to do a 7th root, raise to the 1/7. 10th root, raise to the 1/10. How about a 5th root? What would we raise this to that would represent doing a 5th root? To the what? 1/5. To the 1/5. Yep. And this is the reason why we might change it to an exponent, is because now you have a power to a power. And does anybody remember what you do when you have a power raised to a power? You do something with the two powers. Yep.
Multiply.
You multiply it. And what's 4 times 1/5? Yep. Oh, you're not sure.
4/5.
4/5. Yeah. So when you have a power to a power, you can multiply. Right? Any questions, especially on that last one? This idea of writing roots as exponents, that's going to come up when we do our last type of function we studied in chapter 5, next academic week. Okay, but we're talking about radicals, so it also comes in when we study radicals. All right, so what does it mean if you see directions that say to solve some type of equation for the principal root? Well, first of all, principal root means that they are looking for one answer. Let's start with that. Looking for a single answer. Now, we should know when we take, for example, a square root. When you do the square root of 25, what do you get for an answer? 5 times 5 is 25. What other number times itself is also 25? Yeah? Negative 5. So when you do a square root, there are 2 answers. General rule is whatever your index is, that's how many answers there are. If you're doing a cube root, There are 3 answers mathematically to the problem. Some of them, though, are imaginary, and we're not going to do the imaginary ones. When the directions say to find a principal root, they just want a single answer. And we can kind of break down what does that mean into 2 cases, even index and odd index. So if the index is even, we want a positive solution. We want a positive solution. The other thing that will happen, if the index is even, okay, let's take, for example, a square root. What kind of numbers are we allowed to take the square root of and not get imaginaries? What the radicand has to be what number or higher? Yeah?
0 or higher.
0 or higher. So the other thing that we always have to watch out for, when we are doing even roots, the radicand has to be 0 or higher. If it's not, and they ask you to find the principal root, that wouldn't make sense, because you'd be getting you'd be getting an imaginary answer, and we're not getting into imaginaries. All right. So if I said to find the principal square root of 36, there are 2 answers, but what would be the answer that I want? I would want 6, yes, because that's an even root, and I want the positive solution, and it is a problem you can solve because the radicand is 36, and that's definitely greater than 0. All right. Now, if n is an odd index, okay, if that number that I have circled right there is an odd index, the solution can be positive or negative. Could be either one. Solution can be positive or negative. They both work. And the other thing about this one is the radicand does not have to be greater than or equal to 0. It can be anything. You can do you could do, for example, a cube root of any number. Doesn't matter. So let's think about something like this. Cube root of 8. That's an example that would fall into the second group. It's an odd index. What times itself 3 times gives you 8? 2, right? Now, let's try something we couldn't do when the index was even. Let's try a cube root of a negative number. Is there a number you can multiply by itself 3 times and get negative 8? Negative 2, yeah. So having a negative radicand is fine. You will not get an imaginary answer when you do a cube root. Right? The principal cube root. There would be no imaginary answers. You can do any real number can be under the radicand. Now, let's say you don't know how to type that in on the calculator. Let me show you how you type in a cube root. Let me start with something simple. Let's do square root. For square root, there's a button. You can press second, and then it's the 5th button down on the left-hand side. And that's how you type in square root. Now, if you want to type in a cube root, these are the buttons that you press. Start with the index you want to do. If it's a cube root, you're going to press 3. After you press 3, you press math, and then you're going to go down to option 5. So it's math, and then option 5. It will now change that 3 that you typed in to be the index. And now if I type something in, like the cube root of 64, I get 4. All right, so to do a root that's not a square root, press your index, whatever number you want. So you want to do a fifth root. And then math, and go down to the option that has that little X symbol near the root. And now you can do a fifth root. Now, if I was doing a fifth root, does the radicand have a restriction on what number it can be?
No.
No. All right. If the index is odd, the radicand can be any real number. Doesn't matter. You could take the fifth root of a positive number or a negative. Or 0. You can also take roots of 0. All right. Any question on those ideas, what the idea of a principal root is? It's just a single answer to the problem. With even roots, it'll always be positive. With odd roots, it could be positive or negative. All right, so now, kind of tying this in with the first slide. So remember we had the font radical, right? The rad. So now look at this one. Smaller or larger. And smaller is smaller and larger is larger. That's cool, right? Can't beat that. All right. So let's see what happens. When we take, I got a number in the left, and on the right, I want to take the square root of it. What's the square root of 4? 2. So in that case, when I took a square root, did it get smaller or larger than what I started with? It got smaller. Okay, let's try the square root of 18. 4.24. Is that smaller than what I started with or larger? Okay, that's also smaller. So it looks like when you take the square root, it gets smaller. Well, let's try 1. What's the square root of 1? 1. Well, that didn't get smaller, so now that one stayed the same. All right. So maybe taking a square root, it either stays the same or it gets smaller. Well, let's see. Let's take the square root of 0.5. 0.71. So what happened that time? It got larger. So the point I'm trying to make is when you take a root, you can't necessarily answer when you're done, are you going to get a result smaller or larger than what you started with? The answer is it depends. Okay? Anybody think they know when you can take a square root and it will get smaller? If you take the square root of certain numbers. Yep.
It's greater than 1.
If it is greater than 1, then yes, the square root will get smaller. If it is less than 1, the square root will get larger. It has to be less than 1, but it can't be negative. We already talked about negatives. Okay. So between 0 and 1, it would get larger. All right, so let's graph a couple roots that have even indices. Let's do like a square root and a fourth root. And I just want you to see what they have in common. Okay, because they will have something in common. A couple things. So here's the square root. And how do I do a fourth root?
You type in a 4.
4.
And then
Math.
5.
Option 5. Okay. So I'm going to graph those. I'm going to do the standard window. And let's see what it looks like. There's a square root. And there's a fourth root. Okay. What's one thing you notice about both of them? Anything you notice that it looks like they both have in common? Yeah?
They both start from the same place.
They do. They both start from the origin. We're going to zoom in and see that a little bit closer in a second. Anything else you notice about both of them?
They're both increasing.
Yeah, they're both increasing as you go to the what? To the right. Yes, these both go to the right. Yep. Yep.
Those look like half parabolas, but they only have one side.
So yeah, the square root one is half of a parabola. The red one is a fourth root, so I'm not sure we have a name for that for a fourth root, but it is half of another shape. Yeah, it's like it's half of it. Yeah. I'm going to zoom in just into quadrant 1 so we can start to see that a little better. So I'm going to make it so it takes up more of the screen now. So there's the square root. And there's the fourth root. So maybe you can see something else now. Let's look at that. Did anybody notice anything else that those two graphs both have in common?
They intersect twice.
Yeah, they do intersect twice. You know, it doesn't look like it, but it starts to get really steep in here. So that's why I didn't draw that red part. But they both start here, and they intersect here. What coordinate is that?
1,
1, 1. Yep. So on an even root graph, all even roots will go through the point 0, 0, and 1, 1 as long as you don't transform them. If you take a graph like a square root and you do a +2 on the end, that's a vertical shift up 2. The graph is no longer going to go through the origin because you shifted it up 2 units. Okay? So when I talk about even roots going through both of those coordinates, I'm talking about the basic graph. No transformations done to it. What about the domain? What's the lowest value that they go on the x-axis? The furthest left, 0. And the furthest right?
Infinity.
Infinity. Yep. And it does reach 0. You can tell that by going to the table and typing in 0, and it doesn't say error. It gives you a value. If you try to go negative, it will say error because the graph doesn't go in the negative direction. It only goes positive. But it's going to go to the right forever. How about how low does it look like the graph goes?
0.
0. And how high?
Infinity.
Yeah, it looks like the red one starts to like level off, and even the blue one. But if you look at the table and you just keep plugging in bigger and bigger numbers for x, the numbers for y just continue to get bigger and bigger. The fourth root gets bigger, but it's very slow. All right? But it does keep going up forever. Just think of it, it's like half of a parabola. Right? Parabola is like it just keeps getting wider and wider as you keep going. Right, so that's a couple of properties with even roots. Now, let's look at odd roots. And we'll do the same thing. Okay, so I'm going to do the two most basic odd roots, a cube root and a fifth root. So I'm going to do 3, math, 5. And since I already have my index there, I can just highlight it and change it to a fifth root. And I don't have to go back in and type it all over. Let's start with zoom 6. And I think you'll notice a very big difference right away. That's a cube root. What looks very different about odd roots? It goes into the negative section, right? We said the radicand for an odd root can be any real number. The radicand is your domain. It goes in both directions. So let's put that back up. So yeah, it goes in both directions. Let's zoom in because you can't really see much else without making the graph look a little bigger. So I'm going to make it so it takes up more of the screen now. It gets pretty steep in the middle, and it almost looks like it skips. It shouldn't do that. Okay, this is connected. You never lift your pencil as you're drawing it. All right, and now let's make that a little bigger and take a look. Okay. Anything you notice about these graphs? Assuming again this part in the middle should be connected just like that. They intersect 3 times. Yes. They intersect at the origin. And where else?
The positive quadrant and negative quadrant.
Yep, and what's the coordinate where they intersect in the upper right?
1, 1.
1, 1.
Negative 1, negative 1.
And negative 1, negative 1. Yep. So all odd roots, if you don't transform them, will intersect at those 3 points. Negative 1, 0, 0, and 1, 1. Now let's look at the domain. How far left and right do those graphs go? Right, they go left and right forever. That's different than an even root. And how far up and down do they go? Yep. So both the domain and the range for odd roots are all real numbers. So there's just a few special properties of odd roots. And I could do a 5th root, a 7th root, a 9th root. I could keep doing more and more roots, and they would all go through those points, as long as I don't shift them up and down or shift them left and right, things like that. Questions on that? Okay. So speaking of shifting up and down, shifting left and right, we're going to look at those transformations now. I don't have as much space as you probably do, so I'm just going to put it over here. Okay. There are 6 transformations that can happen with radicals, and they're exactly the same as all the transformations we've studied for every function we've done all year. So let's start with A. A and B are what I'm going to be considered inside the function. In this case, it actually means under the root. Adding or subtracting on the inside. Does anybody remember what that kind of thing does? Yep.
Shift left and right.
Exactly. That's a horizontal shift. Adding or subtracting is always a shift. If it's inside the root, it's horizontal. If it's outside the root, well, I'll talk about it in a second. Which way does positive move the graph? Positive moves it left. Negative is right. The A is backwards. And so is the B. What kind of transformation is B? It's still inside the root, so it has something in common with A. But now it's multiplication instead of addition. Yeah?
Horizontal stretch.
It's still horizontal. Everything on the inside in the red box is horizontal. But it's a stretch. And remember, if you had a big number, it actually makes it smaller. So if you had something like this, and I said to describe the square root of 3x, you would say horizontal stretch by factor of 1/3. So the bigger you make this number, the more squished it gets. Okay, horizontal is always backwards. If you wanted to actually stretch it bigger, then you would use a small number, like this. That would be a horizontal stretch by a factor of 2. It's a small number. Small numbers stretch it bigger horizontally. Okay, what about C? C is like B. It's multiplication, but it's outside instead of inside. Yeah?
It's a vertical stretch.
That's a vertical stretch, and that is not backwards. The bigger you make the C, the bigger stretch you get. So if you put like 5 times the square root of x, that's a vertical stretch by factor of 5. Okay. Vertical transformations are never backwards. And how about D? It's addition, but it's on the outside.
Vertical shift.
That's a vertical shift. And that also is not backwards. So positive, if it's not backwards, would be which way?
Up.
Up. and negative, down. Now, I said there's 6 transformations. I only described 4. What are the other 2 that can come up? Yeah?
The root at the end, and then reflection over the axis.
So the reflections, yeah, this root doesn't really matter, okay? Because you're always going to be comparing a square root to a square root, cube root to cube root. You'd never compare like a 4th root to a 5th root. They're not the same root family, okay? You've got to compare 2 that are the same. So yes, it would be the reflections. So let's just write those down. If B is negative, what kind of reflection would that be? If B is a negative number. Well, think about what kind of direction does B affect? Horizontal or vertical?
Horizontal.
Horizontal. So if B is negative, it's a horizontal reflection. So if B is negative, that's a horizontal reflection. Horizontal reflection looks like this. It's a reflection over the y-axis, left to right. All right. Now, how about if C is negative? What would that be? Yeah, that would be a vertical, because C affects vertical stuff. And if C is negative, it would be a vertical reflection. Vertical reflection would look something, that's usually my standard example. It would flip up to down, which is over the x-axis. Okay, so now that is all the transformations. You generally don't have all 6 in the same problem. You could, but generally you don't. All right, so let's try this one. So we're going to compare the square root of x minus 2 to the square root of x. Yeah,
If C is negative, what was it again?
vertical reflection.
Vertical.
First thing we want to do is just figure out how many transformations there are. How many things would you have to do to change that into that?
Subtract 2.
1. Yeah, you just have to do one thing. Okay. Now, when you are listing the transformations, if there's more than one, the order is important. And the order follows those letters. Start with A, then B, then C, then D. That's the order you follow. There's only one transformation, so order is not important. But what is the transformation? Yeah.
I was going to ask about the order, but the transformation is a horizontal shift
Yep.
2 units to the right.
So that's a horizontal shift. Negative means it's going to go to the right 2 units, and that's what I'm looking for.
But my question was, for the order, do we put the reflections before the letter? Like if, say there's reflection over the y-axis, we do that before we say whatever B was?
So that part, it doesn't really matter. So if you wanted to write the order of all 6, the first one you do is the horizontal shift. Then you could do the horizontal stretch. Then you could do the horizontal reflection. But if you switched the stretch and reflection, it wouldn't make a difference. Then you would do C, which is vertical stretch. Then you would do the vertical reflection. And then the last one you would do is D, which is the vertical shift. Okay, so that's the order I would follow. Definitely want to do all the horizontal stuff first, and then all the vertical stuff second. But that's just following A, B. So this, if I kind of color code it, This is A, this is B, that's also B, that's C, and that last one is D. So B and C can each do two things. Okay, does that make sense? Okay. Let's try another one. How about that one? How many transformations, first of all, will it take to change the basic graph into h of x? Yep, just one. And what is the one transformation?
Horizontal shift left.
Horizontal shift. Which way?
Left 3 units.
Left 3 units. Yep. All right, and let's look at this one. Okay, so looking at k of x, what's wrong with how the radicand is written if we're trying to compare it to that template?
The x comes after.
Right, the x should be first if you want to compare it to exactly what I wrote. So how could we fix that?
Negative x plus 3.
Negative x plus 3. All right, now, how many transformations would it take to change square root of x into what we have there?
2.
2. What would be the first one?
Horizontal shift left 3.
So start with the a value, and there is a number there, so shift left 3. If you don't say horizontal, that's fine, because left it covers the direction. So shift left 3 is fine. And then what would be the last thing? Right, that's a reflection over the y-axis. So think about what a horizontal reflection would do. When you draw a square root, which way does it normally curve? Yeah, it normally curves to the right. If you reflect it horizontally, what's going to happen? Right, it's going to curve to the left. So even roots still only go in one direction, but they can go in a different direction if you flip them. Yeah. You could also flip it down like this, so it could curve that way. Or if you reflected it twice, it would look like that. So that's kind of the general look of even roots, reflected every possible way you could reflect them. All right, any questions on that one? Okay. So now, the last two things we're going to look at are sketching, and then we'll finish up with solving some basic radical equations. There's two categories of roots, even and odd. When you sketch an even root, the point that's at the origin, I refer to that as the start point. Okay. When something has a start point, that means it has a place that it begins at, and then it goes in one direction. When we sketch something that's an odd root, that doesn't have a start point. That has what I would call a center point. So we find the center, and then we end up sketching in each direction. Okay, so this would be called a start point. This would be called the center point. So even roots always have a start point. Odd roots always have a center point. Regardless of what you're calling it, start or center, that's the first point you need to find when you're sketching a transformation. Find the new start or center, depending on what kind of root it is. Okay. And here's how you find it. When you are finding a new coordinate, you're finding a new x and you're finding a new y. So there's two numbers to find in a coordinate. To find the x value, you take what's under the radical and you set it equal to 0. That's how you find your new x value. Take what's under the radical and set it equal to 0. So if I was doing that problem in red, and I said to find where that one is going to start, I would take x plus 3, and I would set it equal to 0. And I'd solve it. And that'll give me the x value. Now, once I know the x value, well, you tell me, if you set that equal to 0, what do you get? If you set the radicand equal to 0 and solve. Negative what? Negative 3. So from the first step, you get negative 3. Now you would plug that back in right there, do the math out, and then it'll tell you what y is. Okay, so first you find x, then you plug it in, and you get y. And what that gives you is the start point, or the center point. Depends on which type of problem you're doing. If you're doing an odd root, those are going to be more work, because an odd root goes in both directions. So you're going to have to sketch some points to the right, and you're going to have to sketch some points to the left. If you're doing an even root, that's less work, because it only goes one way. So you just have to check points in one direction. It is important that you check points going the correct way. If you check points that go the wrong way, they're going to be imaginary. That's not going to help you. So we're going to be checking the points on the calculator. That's how we're going to do it. Okay, we're going to use this. Okay, so odd roots, you got to do left and right. Even roots, just one way. I can't say which way it is. It could be left or it could be right. Depends if you flipped it. Okay, so I think we'll try sketching one odd root and one even root. Try one of each. Okay, so just before we even do anything with example 2, is example 2 going to have a start point or a center point?
Center.
Yes, it's going to have a center. How do we know that?
Use
It's a what root?
cube root.
Yeah, it's a cube root, which is a
Odd.
odd. That's the key. The root is odd, so it's going to have a center. How do I find the x value of my new center point?
Set radicand to 0.
Set the radicand equal to 0. So 3 minus 2x equals 0. Don't worry about anything that's not in the radicand. That doesn't affect the x value. So I would do this first. Now I don't have to deal with a negative number. And what would be my last step? Yep, divide by 2 by 2. That's gone. And if you want a decimal, because we're going to graph it, x is 1.5. All right. Now, how do I get the y value?
Substitute.
Yeah, substitute 1.5 back in. If we plug 1.5 back in right here, what's 2 times 1.5? 3. And what's 3 minus 3? Well, we already knew we were going to get 0, because that's how we got 1.5. We set it equal to 0. So if you plug it back in and you don't get 0 right away, then something's wrong. Okay. So we get 3 minus 3 is 0. What's the cube root of 0? 0 times 2? 0 plus 1? 1. Your y value is usually just that number right there. That's your y value. But if you forget that, you can always just use substitution. It's just the whole first part comes out to 0. All right, now let's make a sketch. Okay, so So our center point is 1.5, 1. And is this the kind of problem that goes one direction or both?
Both.
Both. So I'm going to check 3 points to the right of my center, and I'm going to pick 3 to the left. Doesn't matter what you pick. My graph paper only goes from -10 to 10, so I'm going to pick values between -10 and 10. Okay, so let's put that in. And just be careful typing it in. It's 2 times, and it's not 2 times 3. It's not going to do 6. It's going to change that 3 into the cube root. So it's 2 times the cube root of 3 minus 2x, and make sure when you do the +1, you are not under the root. Okay, let's go to our table. Let's check the center, make sure we did that right. Yeah, 1.51, that's exactly what we got. And now I'm going to pick a couple more points. I'm going to do like 4, 8, and 10. Let's do 4, 8, 10. And I'm going to do some points the other way. Let's do 0. That's a good one. Oops. All right, so we got 0. And then let's do -5, -10. -5, -10. Okay, so that's should be enough points for us to see our curve. All right, so we got 4, 1.5, 1. We got that. 4, -2.5, roughly. 8, just above -4. So 8, 1, 2, 3, so about right there. 0, we're just below 4. -5, we're just below 6. About right there. And -10, just above 6.5. 1, 2, 3, 4, 5, 6.5. Yeah, that looks pretty good. So now just draw your curve best you can. Like that. All right. And that's how you sketch an odd root. So you start with the center, and then you find some points left and right. Any question on that one? Okay, so let's try an even root. So it's 3 times the 4th root of 4 minus 3x minus 2. How many transformations are there? Just looking at that one. We're not going to write them out, but if I did ask, how many would you say? 5. There's a horizontal shift, a horizontal stretch, horizontal reflection, vertical stretch, vertical shift. So this one has a lot. It doesn't really complicate graphing it because we use the calculator anyway. So, all right. Does this graph have a start or a center? Start. How do I find how do I get going to figure out my starting point? Set the radicand equal to 0. All right. And my last step? Divide by 4. That's right, divide by 3. And there's the x value, 1 1/3, 4/3. Now, we got the x value. We still need to find the y value. So what do you do with the 4/3? Substitute it back in. What's 4 divided by 3 times 3? 4. 4 take away 4?
0.
So better be, because that's what we just did. So that's 0. What's the 4th root of 0? Times 3? 0. Minus 2? Negative 2. So my start is 4/3, negative 2. Okay, so 1 1/3, -1, -2. About right there. Okay, let's put that in the calculator. And does this graph go in one direction or both directions?
Just one.
Just one. So we got to make sure we are checking points on the correct side. Think about which way this one is going to curve. Which way is this graph going to curve? Ariel?
It's gonna be this, because it's horizontal shift, right? Or,
Horizontal shift would not affect which way it curves. Yeah?
It's a horizontal reflection.
There is a horizontal reflection, which means it's going to curve to the left. So that means you can only plug in x values that are below -1, -4/3. Okay? If you try to plug in an x value higher, that's what will happen. All those values are higher than 4/3, so we can't use them. I think those values we already have are fine. So let's just use those. I'll just put it over here because my graph is not going to go up into quadrant 1. So we got 0, 2.2, -5, 4.2, and -10, 5.2. All right, so there's your graph. Something kind of like that. Now remember, it does get very steep in that section. So if you try to draw it, the calculator is probably not going to show it as good as the drawing I did. Okay, it doesn't even look like it goes below the x-axis, but that's definitely wrong. Does everyone agree it doesn't look like it goes below? Now watch what happens if you zoom in. It doesn't look like it goes below, but then you zoom in on it. Now does it look like it goes below? Yeah, it's getting too steep. The calculator can't draw it. So it doesn't look like it's going as low as it should though. It should be going down to -2, like we have. Okay. All right. So any questions on that? All right, so that's the basic properties, the transformations, the sketching. So now the last thing is solving some equations. The way that you have to solve a radical equation is the first thing you got to do is make sure that your radical is isolated. Make sure that it is by itself on one side. Here's an example of a radical that's by itself. There is nothing else on the outside of the radical on the same side. Okay. So something like that, that one's good. That one's ready to go. How about something like this? No, that one's not good. The reason that one's not good is because there's something on the outside of the radical that we don't want there. So our first step would be we'd have to get that 3 on the other side. And how would you move the 3 over? Yeah, you divide by 3 on each side. Yep. Okay. So that's your first step. Make sure the radical is by itself. And then you raise each side to a power. That's how you get rid of the root. Raise each side to a power. The power that you use has to cancel out the root. What kind of root is this one? It's a square root. What's the index on a square root? 2. So that means you would raise each side to the second power. If you had a cube root, what's the index on a cube root?
3.
It's a 3. That means you need to raise each side to the third power. Yep. You do have to check your answer, because it is possible that you get a solution that does not work. solve a few problems algebraically, and that will be it. Okay, so let's try. What example? I think we're up to example 4. So let's try the square root of x minus 5 equals, I don't know, 7. First thing you want to look for is the radical isolated on one side. Yes, there's nothing outside the radical on the left side. What kind of root do we have? We have a square root. So what power would we raise each side to?
The second.
Second power. When you have a square and a square root, those cancel out. And what does that leave you with on the left? X minus 5. Okay. And how about on the right? 49. And what would be your last step? Add 5. And for our answer, we get 54. Let's check it. What's 54 minus 5? 49. And what's the square root of 49? Principal, because it's principal. Yeah, it comes out 7. Yep. We know it's a principal root because when you see that symbol means principal root. If they want the non-principal root, or they want both answers, you'll see a plus or minus in front. This one doesn't have that. Any question on that one? All right, let's try this one. Let's do 3 times the square root of x minus 10 equals 21. Okay. Is the square root by itself? No. Okay. It doesn't even matter at this point what is in the square root box. Just think of it like that. It's 3 times something equals 21. You can't have the 3 times. That 3 times needs to go to the other side. So how would we get rid of the times 3? Yeah. What would you divide by?
3.
Divide by 3. That cancels. And now we do that. So all that we have left now is the box. What's in the box? Now that's important. Square root of x minus 10. And 21 divided by 3 gives me 7. Okay. Now what power would we use on each side? Second power. Square and square root cancel. That leaves me with x minus 10 equals 49. And then when we move the 10 to the other side, we're going to get x equals 59. Perfect. Okay, let's check it. What's 59 minus 10? 49. Square root of 49? 7. And 7 times 3. And that's what we started with. Yep. Okay. Any question on that one? All right. Let's try this one. Let's do 3 plus 4 times the square root of x minus 9 equals, let's do, let's say, negative, let's do negative 21. Yeah, that'll come out nice. Okay. Is the square root by itself? No. So we need to fix that. And again, think of it like it's this. Don't worry about what's in that box right now. Just worry about getting the box alone. What would be your first step if you were trying to get what's that box by itself?
3 and 4.
Well, we can't do that because that's multiplication. Okay, so remember, that's multiplication times what's inside that box. Yep,
Subtract 3.
subtract the 3. Okay, so that's gone. 4 square root x minus 9. And what would be on the other side? Negative 24. All right, are we ready to raise each side to a power now? No, the radical's still not by itself. So what do we have to do now?
Divide by 4.
Divide by 4. That's gone. And what's negative 24 divided by 4? Negative 6. Now we've gotten this down to the kind of problem that we started with. What do we do on each side to get rid of that root?
Raise to the power 2.
Raise it to the second power. Square and square root are gone. That's x minus 9 equals 36. And when I move 9 to the other side, my final answer will be 45. And now let's check it. And I'm just going to circle, this is what we had originally, so we remember. What's 45 minus 9? 36. What's the square root of 36? 6. What's 6 times 4?
24.
24. And what's 24 plus 3? 27. Okay? That's not what we were supposed to get. So we were supposed to get negative 21. What that means is that this is extraneous. It doesn't work. Okay, because we plugged it back in and we got, I think we got 27. And we were supposed to get negative 21. Okay. Okay, so any questions on solving square roots?
What if you use -6 instead?
If you use negative 6, let's see. So if you did 45, so pretending like there was like a minus sign in front of that square root.
Yep.
Okay, let's see. So 45 minus 9 is 36. The square root of that is negative 6. Negative 6 times 4 is negative 24. And then negative 24 plus 3 would give you negative 21. So yeah, if this problem was written like this, plus 4 times the negative square root of x minus 9 equals negative 21, then it would work. But we don't have that, so we can't use that. Very good. Okay. Any other questions? Okay. So let me put up the homework. I'm just going to adjust a couple things. So I'm going to rewrite it. So let's do 5. Do 12, 14, that's good. So let's just do 19, 20, 22, and skip 21. We're going to skip 28, I'm not doing that one. I'm going to skip 31, and we're going to skip 35. So that's good right there. Okay, so I'll put that there, and we still got, you got 20 minutes So you can use the time to try to get some of that done. It's only like 10 questions, I think. 9 questions. So you might be able to get half of it done. And I'll put the list for the topics that are going to be on the test.
Are you gonna put them up while we're in the class? Or are we gonna do them over